Welcome back, students. We'll be discussing about this problem. Where in two blocks A and B weighing 4 kilonewton and 2.5 kilonewton respectively are connected by a wire passing on a smooth, frictionless pulley. So it is not offering any friction. This is a pulley. Okay, at first you have to identify where's the pulley. Determine the magnitude of the value P. So they have asked you to find the value of P. Where is this value of P? Where is this P existing? P is existing here. You can see block A and block B. Block A is weighing 4 kilonewton and block B is weighing 2.5 kilonewton. And they are not telling that how it is moving, where it is moving. We have to understand, we have to predict, we have to analyze the problem such that both the blocks are being pulled up by the force P. So now we have to determine what is the value of P. So what could be the possibility of block A moving up or down, block B moving right or left, how it may start moving, because block force P is being applied in this direction. So eventually you can see this block A will move in this direction. The motion of the block A will be in that direction. Similarly, block B will be moving in this direction. Correct? So the friction developed at this point will be opposite. At this surface it will be opposite. Okay, and keep in mind, students, when it is a fully coming up over here, there's no friction, but tension. It's a string connected, wire, string, whatever, tension will come into picture. So what is the, when I'm talking about wire or a string, there is a tension. So tension will be in this direction. Equal and opposite tension will be in the other direction. You can see both are equal and opposite. Now we'll start drawing the free body diagram of block A at first. So block A is, this is the angle. So this is the plane and block A is here, correct? And what is the angle? 60 degree. The diagram is not to the scale. And the weight of the block is 4 kilonewton. So before that, I'll drop the axis, correct? So the axis will be in this, along the plane, right? The x-axis will be along the plane. The x and y-axis. Okay. Now I'll indicate the force. Okay, I'll pick one color, and this is the force which is acting. What is the magnitude of the force or the weight of the block A? 4 kilonewton. So this is 4 kilonewton. At what angle this is? At an angle of 60 degree. So therefore this angle will be 30 degree. The diagram is not to the scale, students. And now what about the motion? The motion is in this direction. The friction will be in the opposite direction. So the friction will be opposite direction. Okay, I'll take this color and friction, I'll call it as F1 and N1. Okay, so this is the free body diagram of block A, correct? Similarly, I have to draw the free body diagram of block B. Am I correct? Block A and block B? Yes, it is block A and block B and block B. Okay, very important thing I forgot to write here, because the blocks are being attached by a string. There's a tension in the member. So there's a tension in the member. I'll be showing the tension in this direction as T. Okay, now I'll draw the other block B free body diagram, which is on the horizontal plane, Okay, and the block is placed on the horizontal plane. So axis, I need not worry. This will be x-axis and this will be y-axis, correct? And now I'm supposed to refer the tension T which is equal and opposite T. And what about the friction? What is the moment of the block B? The block B is pulled in this direction. Okay, so your friction will be in the opposite direction. So the friction will be in the opposite direction as F2 and N2. F2 and N2. And you find the force P. I'll resolve this force P. Okay, so that it is convenient for me. So this is P cos 20 and this will be P sin 20. Okay, P cos 20 and P sin 20. That is our diagram what you find here. Okay, now to start with, I'll start with the block 4 kilonewton. This block A, right? Because number of unknowns are less. T is unknown, N1 is an unknown, F1 is unknown. Here P is unknown, F2 is unknown, N2 is T is unknown. So many unknowns are there. I'll start with the less number of unknowns. So apply equations of equilibrium to block A. Okay. So I'll write sigma H is equal to 0, wherein all right moving forces positive, all left moving forces negative. So what I can call it as, so minus F1, okay, see to the diagram, minus F1, then plus T, then minus 4 cos 30 will be equal to 0, right? 4 cos 30, this is the 4 cos 30. So 4 cos 30 is equal to 0. So you find I can write it as T is equal to 4 cos 30 plus F1. I call this as equation 1. Okay. Next, I'll apply equation sigma V is equal to 0. Calling all upward forces positive, all downward forces as negative. So give me the equations now. So you find minus and plus N1. Okay. So it will be minus 30. Sorry, minus. I strike off. So minus 4 sine 30 and then plus N1. And any other force in vertical? In vertical, you find any other force? No. You find N1 and 4 kilonewton. So I'll resolve it. I'll get N1 as some value as 4 sine 30. Correct? So when I calculate, we know what is that we know? Mu is equal to F1 by N1. Okay. Once I calculate N1, I can get the value after substituting here. I can calculate what is F1. Once I calculate F1, after on your calculation, I can calculate what is the value of T. Correct? So T value, I get the value as 3.864. So T is equal to 3.864 kilonewton. Kilonewton or Newton it is? Yeah, kilonewton. Okay. So I get this value. Similarly, I should continue applying equations of equilibrium to block B. So apply, because the unknown is P, apply equations of equilibrium to block B. Correct? It is block B, right? Right? Or block, yeah, 2.5, block B. So sigma H is equal to 0. All right moving forces positive, all left moving forces negative. Now I see minus T. Okay. Then plus P cos 20. Then What is the F2 value? We have F2 direction. F2 is minus again. Minus F2. Minus F2 equals to 0. I have the value of t. I can substitute the value of t. What is the value of t I have? 3.864. So it is, our F2 is equal to t minus, sorry, minus t plus p cos 20. And F2 is equal to, I'll substitute the value of minus 3.864 minus 3.864 plus p cos 20. I call this as equation 2 if I'm correct, 1 or 2. Then I'll go with the next equation, sigma v is equal to 0, upward positive and downwards negative, right? So upward, downwards, yeah, upwards and downwards. Here I forgot to take the load of the block, that is how much it is, 2.5. So I'll write the equation here only, it is more comfortable writing here. So sigma v I'll apply here. So minus 2.5 plus N2 plus P sine 20 equals to 0. So N2 is equal to, I can call it as plus 2.5 minus P sine 20. Upon solving all the equations, right, we'll get the end result as value of P as, after solving all the equations, we'll get the value of P as 4.329. Okay, students, with this learning, I'll end the session. Thank you all.